2. Introduction. The chemicals present in the environment can be harmful to the structure and function of the ecosystem. Chemical substances in the environment are the major cause of global problems. Natural substances as well as man-made artificial xenobiotics compounds are harmful when unusually distributed in the environment and also enter the element cycle of the ecosystem. There are a large number of toxic chemicals produced by plants, fungi and animals. Various natural activities like soil leaching, volcanic eruptions and anthropogenic inputs are the different sources through which metals are introduced in the aquatic environments, the sea being the final acceptor of these toxic compounds. Remade, 1992. The science of toxicology is the study of toxins, poisons, and their effects on living systems. Toxicology is a broad field derived from biochemistry, pathology, histology, pharmacology and several other disciplines. In 1960s the term ecotoxicology was introduced for the study of environmental toxicity caused by both natural and artificial substances on living organisms present in the nature. Environmental toxicology or ecotoxicology specifically deals with the interactions, transformation, fate and effects of natural and synthetic chemicals in the biosphere, individual organisms, populations, community and whole ecosystems. 3. According to Newman 1998, ecotoxicology is the science of contaminants and their effects on the constituents of biosphere. Thus, ecotoxicology can be defined as the study of toxic effects of chemicals like hazardous wastes, industrial chemicals, heavy metals, pesticides and fertilizers on the organism, population, community or ecosystem. It is a multidisciplinary science and represents a multi-step process to describe the sources, pathways and effects of chemicals that are harmful in the environments. The main reasons for measuring the ecological effects of chemicals are to predict how toxic substances are likely to impact ecological system. Various tests are done to chemicals prior to their release into the environment and on existing chemicals for which actual effects are still unknown. To assess various changes occurring in ecological systems under the influence of released substances, so to assess the environmental risks of the chemicals. 3. Environmental toxicology. 3.1. Basic functions described by environmental toxicology. 1. Fate and transport of chemicals in the biosphere and the living organism which are released into the environment. 2. The interaction of the material with the site of action. 3. Impact of molecular interaction of toxicants upon the function of the ecosystem. There are many sources of toxic and hazardous chemicals in the environment whose route or method of exposure and their persistence in the environment as well as characteristics of the target organism. Figure 1 that determine the danger of the chemical. The dose, entry route, duration of exposure and sensitivity of the organism all play important role in determining toxicity. 3.2. Types of ecotoxicants. There are more than 200,000 man-made organic compounds and toxicity of most of these compounds are not yet known. The risk of these compounds can be assessed by following information. 4. 5. I. Estimated amount to be produced. E. Intended uses. E. Tendency to disperse in the environment. IV. Its persistence. B. Conversion of toxicants into different forms. B. Effects of these compounds on individual and ecosystem. Broadly, the chemical agents can be categorized in two types. I. Toxic chemicals. E. Hazardous chemicals. Figure point 1. Factor in environmental toxicity. Figure 1. Factors in environmental toxicity. Factors related to toxic agents. 1. Chemical composition and reactivity. 2. Physical characteristics such as solubility, state. 3. Presence of impurities or contaminants. 4. Stability and storage characteristics of toxic agent. 5. Availability of vehicle, such as solvent, to carry agent. 6. Movement of agent through environment and into cells. Factors related to exposures. 1. Dose, concentration and volume of exposure. 2. Route, rate, and site of exposure. 3. Duration and frequency of exposure. 4. Time of exposure, time of day, season, year. Factors related to organisms. 1. Resistance to uptake, storage, or cell permeability of agent. 2. Ability to metabolize, inactivates, sequester, or eliminate agent. 3. Tendency to activate or alter non-toxic substances so they become toxic. 4. Concurrent infections or physical or chemical stress. 5. Species and genetic characteristics of organism. 6. Nutritional status of subject. 7. Age, sex, body weight, immunological status, and maturity. Source, U.S. Department of Health and Human Services, 1995. 6. Hazardous chemicals generally include various flammable substances, explosives, sensitizers, irritants, acids and caustics. Toxic compound affect individuals' health by affecting various physiological processes and pose a threat to the ecosystem. The common environmental toxic includes pesticides, heavy metals, oils and petroleum products, domestic wastes, industrial wastes and radioactive substances. Toxic compounds may be of general nature, killing many cells, or they may be extremely specific in their target and mode of action. Xenobiotic substances are those which are foreign to a living system. The various kinds of organic and inorganic substances along with their harmful effects on human health are listed in the table. Point 1. Table. Point 1. Major toxic substances, their source and effect. Toxic, hazardous substance. Source, toxicological effect. Lead paint, gasoline. Inhibition of synthesis of hemoglobin, affects central and peripheral nervous system. Elementary mercury coal combustion causes insomnia, depression and irritability. Ozone reaction of NOx and VOC, volatile organic compound, in presence of sunlight. Irritates eye, upper respiratory system and eyes. Arsenic-treated lumber coagulates protein and forms complexes with coenzymes. Arsenicosis manifest in skin discoloration and other symptoms. Beryllium combustion of coal and fuel oil causes lung fibrosis and pneumonitis. Cadmium batteries causes painful bone disease and kidney damage. Cyanide vehicle exhaust rapidly acting poison. Hydrogen fluoride aluminum production or phosphate fertilizer. Plants. fluorosis, bone abnormality and mottled soft teeth. Hydrogen sulfide, petroleum refineries, headache, dizziness, affects central nervous system. 7. Asbestos, asbestos mining, asbestosis, a pneumonia condition, silica, industrial and chemical. Process like glass making. Silicosis. Phosphine, insecticide use, depression of central nervous system, DDT, pesticide use, breast and other cancer, male infertility. Miscarriage, nervous and liver damage. Carbon monoxide, fuel combustion causes disorder of respiratory system and heart. 3.2.1. Toxic elements and elemental forms. It includes ozone, white phosphorus, elemental halogens, fluorine and bromine, and heavy metals, cadmium, lead, arsenic and mercury. Lead is one of the most prevalent poisons found on the earth. It occurs in the environment due to vehicle exhaust, house paint, ceramic glazing, batteries, cosmetics, lead mining, smelting and coal combustion. Inhalation of lead causes lowering of IQ and heart diseases in the human beings. 3.2.2. Toxic inorganic compounds. The toxic inorganic compounds include hydrogen cyanide, carbon monoxide, oxides of nitrogen NO and number 2, hydrogen halides, etc. Silica occurs in a variety of rocks. It causes an occupational disease commonly called as silicosis when people are exposed to silica dust. Asbestos is a group of fibrous silicates which is commonly used as fire retardant, house flooring and walls. The inhalation of asbestos particles results in a disease called as asbestosis. It is a degenerative lung disease and responsible for lung cancer. 3.2.3. Toxic organic compounds. Some organic compounds and their toxic effects are shown in the table 2. 8. Table point 2. List of some common organic compounds and their toxic effects. Organic compounds, toxic effects, hydrocarbons. Alkane hydrocarbons inflame dry, scaly skin. Alkene and alkyne hydrocarbons phototoxic to plants, irritant to eyes and respiratory system. Benzene and aromatic hydrocarbons, skin irritant, fatigue, headache, appetite loss. Polycyclic aromatic hydrocarbons, benzopyrene is the cause of cancer. Phenols. 2-nitrophenol, pentachlorophenol, O-cresol, M-cresol, P-cresol. Protoplasmic poison, malfunctioning of respiration and circulatory system. Aldehydes and ketones. Formaldehyde hypersensitivity, lung cancer, acetone dermatitis. Pesticides. DDT, aldrin, dieldrin, endosulfan, etc. Affect nervous system. Affect nervous system, loss of memory. Causes cancer, nerve damage, brain damage. Parathion, malathion, skin and respiratory disease. Carbaryl, carbofuran, paraquat, systemic insecticide, systemic poison. 3.2.4. Radionuclides. These are unstable isotopes of elements which continuously undergo decay and as a result emit one or another type of radiation. These are either present naturally or produced in nuclear power plants, use of nuclear weapons, research and medical purposes. It includes uranium, U, krypton, Kr, plutonium, Pu, thorium, Th, and many more. Table 3 presents some radioactive isotopes, their sources and principal modes of decay. 9. Table point 3. Environmental half-lives of some chemical contaminants and radionuclides. Contaminant half-life source. DDT 10 years soil, TCDD 9 years soil, atrazine 25 months water. Benzopyrrolene PAH 14 months soil. Phenanthrene PAH 138 days soil. Carbofuran 45 days water. Uranium 235 7.1 by 108 years nuclear reactor. Uranium 238 4.47 by 109 years nuclear reactor. Cesium 134 2 years nuclear reactor. Cesium 137 30 years nuclear reactor. Carbon 14 5760 years nuclear reactor. 40K 1.3x 109 nuclear reactor. Radon RN 222 3.8 days nuclear reactor. Strontium 89 SR 52 days nuclear reactor. Strontium 90 SR 28.6 years nuclear reactor. 3.3. Distribution and fate of toxic substances. There are a number of ways through which toxic materials enter in the body of living organisms like water, air, food, accidental exposure, medicinal drugs and many more. The solubility of the toxic chemicals determines the movement of toxic in the body of living beings and in the various components of the environment. Water-soluble compounds spread rapidly in the both aquatic and terrestrial system and within the body of the living organisms. Fat-soluble compounds penetrate the tissues which are not used during metabolic processes. Some toxic chemicals are persistent for longer duration in the environment. Some of these chemicals are chlorofluorocarbons, chlorinated hydrocarbons and pesticides. They show additive effect when they are present together in the environment. It is called as synergistic effects, in which one chemical which is less toxic when comes in contact with some other chemical show toxicity several folds higher than the individual effects. The toxicity can be categorized as acute and chronic. The acute toxicity occurs as a result of single exposure to chemicals which immediately show its harmful effects. However, chronic toxicity may occur due to prolonged exposure of sublethal dose. The appearance of symptoms of chronic toxicity takes several years. 3.4. Dose-response relationship. The dose of the chemicals determines the extent of an adverse effect of toxic substance on an organism. The dose-response relationship is used to examine the time-dependent effect of exogenous and endogenous chemicals and physical agents. Dose can be defined as the amount of toxicant per unit of body weight to which an organism is exposed. For example, a dose of lead to a bird might be 5 mg petabit per kilogram body weight. Sometimes dose is expressed as dose per unit time, e.g., 5 mg lead per kilogram body weight per day. The dose response is a quantitative relationship which recognizes that the effect of a certain chemicals depends upon the concentration of the toxic factors. Figure 2. 10. 11. Figure point 2. Dose response curve. Figure point 2. Dose response relationship. The dose dependency can be shown with the help of dose response curve, e.g. by giving different doses of a toxicant to a uniform population of test animals, and the cumulative percentage of death is plotted as a function of log of the dose. Generally, the dose response curve is shaped. The dose corresponding to the midpoint is the statistical estimate of the dose that kills 50% of population and is written as LD50. The dose response curve may differ among different kind and strain of organisms, type of tissues and population of cells. Table 4. Table point 4. LD50 of some chemical substances. Substance LD50 milligram per kilogram effect. Benzene 930 primary irritant, tumorigenic, mutagen, reproductive effector. DDT 80 phenol 310 parathion 2. 100. 50. 0. LD50. P. RE. EC. TN. R. SE. OP. SN. E. Log dose. The ED50 effective dose 50% is the dose which affect 50% of the treated population. The ED50 is more refined as compared to LD50 and can be used to indicate responses such as reduced enzyme activity, decreased reproductive success, and onset of disease symptoms. The goal of dose response assessment is to obtain a mathematical relationship between the amount of toxicant to which an organism is exposed and the risk of an adverse outcome from that dose. The toxic effect due to a combination of chemicals could be of following types. Independent. Each chemical produces a different effect or has a different mode of action. Additive. The combined effect of two or more chemicals is equal to the sum of the individual effects of the chemicals. Synergistic. The effect is more than additive as two or more chemicals can react to create a greater effect than any one of them alone. Antagonism. The effect is less than additive. 3.5. Effect of toxins. 3.5.1. Teratogens. Teratogens are chemicals or other factors that specifically cause abnormalities during embryonic growth and development. Thalidomide is the most commonly known teratogen. It is a sedative drug used by pregnant women which causes abnormality in developing embryo. It leads to phocomelia, in which a baby develops seal-like limbs, i.e., without forelimbs or hind limbs. Perhaps the most prevalent teratogen in the world is alcohol. Drinking of alcohol during pregnancy can lead to fetal alcohol syndrome. It is a cluster of symptoms including craniofacial abnormalities, delay in fetal developmental, behavioral changes, and mental retardation. Moreover, only one alcoholic drink per day during pregnancy results in decreased childbirth weight. According to certain estimates, between 300,000 and 600,000 children born every year in the United States are exposed in the womb to unsafe levels of mercury. The effects are subtle, but include reduced intelligence, attention deficit, and behavioral problems. The total cost of these effects is estimated to be $8.7 billion per year. 12. 3.5.2. Carcinogens. A carcinogen is a chemical or other factor which causes cancer. There are a number of elements or chemicals in the environment which are carcinogenic. It includes synthetic chemicals, radiation, air pollutants, heavy metals, smoking, and chewing tobacco. The carcinogens can be biological, chemical, or physical agents. The biological agent includes retrovirus and HIV. The chemical agents includes nitrosamines and polycyclic hydrocarbons. Xenobiotic chemicals also act as carcinogens. The physical agent includes ultraviolet radiations and ionizing radiations. Cancer rates increased in most industrialized countries during the 20th century and is now the second leading cause of death in the United States, killing more than 500,000 people in 2002. According to the American Cancer Society, 1 in 2 males and 1 in 3 females in the United States will have some form of cancer in their lifetime. 3.5.3. Mutagens. Mutagens are agents, such as chemicals and radiation, which causes sudden and permanent changes in the genetic material (DNA) of living organisms. This can lead to birth defects if the damage occurs during embryonic development. Later in life, genetic damage may trigger neoplastic tumor growth. When damage occurs in reproductive cells, the results are passed on to future generations. Number of chemicals, pesticides, radiations as mutagens. Chemicals frequently reacting with DNA are generally mutagens and also act as carcinogens. 3.5.4. Allergens. Allergens are those substances that activate the immune system. Formaldehyde is one of the most common examples of a widely used chemical that acts as a powerful sensitizer of the immune system. It is directly allergenic and also activates the reactions to other substances. It is widely used in plastics, wood products, insulation, glue, and fabrics. Formaldehyde concentrations in indoor air can be 1,000 times higher than in normal outdoor air. Some people suffer from sick building syndrome characterized by headaches, allergies, chronic fatigue, and other symptoms caused by poorly vented indoor air contaminated by mold spores, carbon monoxide, nitrogen oxides, formaldehyde, and other toxins released from carpets, insulation, plastics, building materials, and other sources. 13. 3.5.5. Endocrine disruptors. These are chemicals that disrupt normal hormone functions. Hormones are chemicals released into the bloodstream by cells in one part of the body which regulate development and function of tissues and organs elsewhere in the body. In some cases, very small concentrations picogram may be enough to cause developmental abnormalities in sensitive organisms. Because these chemicals often cause sexual dysfunction, reproductive health problems in females, or feminization of males, these chemicals are sometimes called environmental estrogens or androgens. There are a number of compounds like phthalate, alkyl phenols, organochlorine compounds, and polycyclic hydrocarbons or xenoestrogens. Fall in sperm count of male and rise in hormone-related cancer such as breast cancer are probably due to environmental estrogen. 3.5.6. Neurotoxins. Neurotoxins are a special class of metabolic poisons that specifically attack neurons. The nervous system is important in regulating body activities, and disruption of its activities is fast-acting and devastating. Different types of neurotoxins act in different ways. Heavy metals such as lead and mercury kill nerve cells and cause permanent neurological damage. Anesthetics, ether, chloroform, halothane, etc. and chlorinated hydrocarbons DDT, dieldrin, aldrin disrupt nerve cell membranes necessary for nerve action. Organophosphates, malathion, parathion, etc. and carbamates inhibit activity of acetylcholinesterase, which is an enzyme that regulates transmission of nerve impulse between nerve cells and the tissues or organs they innervate. Most neurotoxins are extremely toxic and fast-acting. 3.6. Uptake of toxicants. Uptake is the absorption of substance into extracellular fluid for systemic circulation. The fate of the material taken up will be governed by metabolic process. In human, radionuclides have been shown to be absorbed through skin. Radioactive iodide applied to human skin appeared in thyroid gland. The substance inhaled by man may be deposited in nasopharyngeal, tracheobronchial or the alveolar regions of lung. In each of these, the particles are absorbed into the extracellular 14. Fluid are transported up to the pharynx in mucus, propelled by ciliary action. After reaching the pharynx, the material is swallowed into the digestive tract. Materials taken up from alveoli may go to the bloodstream or may be retained in the bronchopulmonary lymph nodes. Dieldrin is absorbed rapidly from the intestinal tract and transported to liver mainly through the portal venous system. However, metabolic conversion is much slower. Only small part is metabolized and excreted, the major part being redistributed into the storage depot of adipose tissue. Methylmercury is absorbed through the gills by freshwater fish, and this respiratory uptake is shown to be dependent on metabolic rate. For terrestrial plants, strontium-90 uptake has been investigated experimentally, and it is shown that foliar deposition is much more important than uptake by the root. For heavy metals also, foliar deposition is more important route for contamination. The understanding of retention of toxicants by organism is useful in determining the toxic effect. It can be obtained by estimation of substance remaining in the body or by measuring the total amount excreted per unit time. Monitoring of excretion value in contaminated organism is also useful. As the most common route of excretion is urine, so the analysis of urine is useful to estimate the toxicant. In case of monitoring of workers contaminated by toxicants, sample of urine and feces are analyzed. For human, ICRP, International Commission on Radiological Protection, 1975, has given information on 30 elements excreted in the urine and feces. Sometimes the concentration of heavy metals in the hair can be measured to calculate the concentration in the body. Sometimes the concentration of heavy metals in the hair can be measured to calculate the concentration in the body. For e.g., the concentration of methylmercury in hair is more than 300 times that in blood. Intake of toxicant from the physical environment, either through epidermis, respiratory organ or gut of terrestrial animals, depends upon the precise form of toxicant, both chemical species and the degree and type of physical aggregation. 3.7. Effects of toxicants on terrestrial environment. The various toxic compounds affect growth in plants, invertebrates and microorganisms. Effects on plant biomass production are related to contamination of soil or air, including deposition on plant surface. The toxic compounds also affect the above ground and foliar. 15. Invertebrates, which represent food for other organisms and perform essential role as pollinators, detritivores, saprophages and pest controller. The effect on terrestrial vertebrates exposed to contaminated food, air, water and soil has social or economic consequences. Poisoned birds and mammals probably constitute the highest social concern, while reproductive effects, although less evident, represent a higher ecological hazard. Accumulation of toxic compounds in food and through food chain represents an additional concern related to the consumption of this food by human and domestic animals. 3.8. Effects on aquatic system. As a result of human activity, large amount of pollutants and toxicants are released into river, lakes, estuaries and oceans. It is well established that heavy metals like lead, cadmium, mercury accumulate in the aquatic organisms. Mercury tends to accumulate in clams. Pesticides affect crustaceans, fishes and mollusks. Oil pollution, oil spill, adversely affects the echinoderms. It is also well established that higher concentration of pesticides and heavy metals accumulates in the aquatic system through food chain. 3.9. Effect of toxicants on human health. Large number of toxicants or pesticides are taken by humans through ingestion, inhalation or absorption through the skin. These toxicants usually affect one or more organs like lung, skin or alimentary canal. Inhalation of asbestos affects lungs, causing irritation in lung lining and finally lung impairment. Sometimes asbestos causes dermatitis when it irritates skin cells. Toxins, when absorbed in the body, are metabolized, transported or excreted. During the metabolic process, they have adverse biochemical effects and causes manifestation of poisoning. These processes are characterized by kinetic phase and a dynamic phase. In kinetic phase, a toxic substance may undergo absorption, metabolism, temporary storage, distribution and excretion. When a toxicant remains unchanged during the metabolic process, it is available for further biochemical interactions as an active parent compound. Some toxicants are detoxified and excreted or converted to non-toxic active metabolites. Figure 3. 16. 17. Figure point 3. Processing of toxicants involving kinetic phase. The dynamic The dynamic phase comprises primary reaction with the receptor or target organ, biochemical effects e.g., impairment of enzymatic reaction etc., and change in behavioral and physiological responses. Figure 4. The immediate and readily observable manifestation of poisoning is changes in temperature, pulse rate, respiration and blood pressure. Central nervous system poisoning may be manifested by convulsion, paralysis, hallucination and ataxia, lack of coordination of voluntary movements of the body. The chronic responses to toxicant exposure are mutations, cancer, birth defects and effects on immune system. Detoxified. Unchanged active patent compound metabolized. Toxicant. Excreted. Further biochemical interaction. Active metabolite to further biochemical interaction. Toxicant. Toxicant plus receptor modified receptor. Enzyme inhibition. Cell membrane disruption. Abnormal translation carbohydrate metabolism disorder inhibition of oxygen utilization in respiration. Alteration in pulse rate, respiratory rate, blood pressure and other vital signs. Hallucination, coma, paralysis, ataxia, problem in immunity. Figure point 4. Dynamic phase of toxicant action Manahan, 2000. 3.9.1. Neurotoxins. These toxins specifically affect nerve cells. Lead and mercury kill nerve cell and sometimes it results in permanent neurological damage. Figure 5. 3.9.2. Effects of lead. Lead is extremely harmful to humans as it damages brain, kidney, reproductive organs and cardiovascular system. Lead poisoning causes decrease in IQ level, delinquency, attention order in children, aggressive behavior, higher blood pressure and hypertension in adults and risk of heart disease. 3.9.3. Effect of radionuclide. The radioactive elements like uranium possessed a great threat to environment and occupational threat to workers. Radioactive waste from nuclear power plant affects the ecosystem, contaminates soil, sediments and groundwater. There are two types of radiations viz. Ionizing radiation and non-ionizing radiation. Non-ionizing radiations from sun is vital to life whereas ionizing radiation produces more complex biological effects. Alpha radiation has a low penetration power, beta particles can penetrate 18. Up to a centimeter, whereas gamma radiation can pass through a living organism and can only be blocked by a thick concrete wall or lead. Figure point 5. Effect of mercury on human body. Exposure to radioactive radiation causes leukemia. Exposure to radioactive radiation causes leukemia, eye cataract and various forms of cancer. These radionuclides when enter the food chain, become more harmful. In food chain, these hazardous substances are taken by grazing animals and humans. Some radionuclides are selectively concentrated within the body of organisms. E.g., iodine is selectively absorbed in thyroid gland and phosphorus is absorbed in bones. Recently, radioactive radon (RN) gas in home has received a great attention. Most of it come from natural sources and is also the product of decay of 238U. It is colorless, odorless and tasteless gas and has been reported as a large indoor air health threat which can greatly increase the risk of lung cancer. When radon is inhaled, it is trapped in lung and releases radiations during its breakdown that damage the lung tissue. 19. 4. Bioaccumulation and biomagnification. Bioaccumulation is the selective absorption and storage of a great variety of molecules inside the cell. Biomagnification is the tendency of some chemicals to become increasingly concentrated at successive higher trophic level of a food chain or food web. Due to this process, toxic compounds which are low in concentrations in the environment can reach to dangerous level inside cell and tissue of living organisms. The figure 6 explains the biomagnification of toxins in the food chain of a terrestrial environment. The dots represent the organic molecules present in each trophic level. The crosses represent the toxin present in each trophic level. The black dots remain relatively constant in each individual, while the concentration of crosses becomes greater in each succeeding trophic level. The concentration system is due to persistence of the toxins, food chain energetics, and low rate of internal degradation or excretion of the substance. Trophic level 1 represents the primary producers. Trophic level 2 represents the primary consumers. Trophic level 3 represents the secondary consumers. Trophic level 4 represents the tertiary consumers. 20. Figure point 6. Biomagnification of toxins in the food chain of a terrestrial environment. The effect of DDT, PCB, heavy metals and radioactive materials get magnified through the food webs. DDT and PCB can accumulate through food chain as these are fat soluble. Due to biological magnification, DDT also interferes with the reproduction of peregrine falcons, bald eagles, brown pelicans, and other predatory birds by causing thinning of egg shells. Metals like mercury and lead can pollute water, air and soil and get into human tissue through food chain. Concentration of some elements is known to increase from lower to higher level. The incidence of neurological disorder affecting many fish-eating people in the industrial city of Minamata Bay in Japan is a good example of biological magnification of mercury. This disease is called Minamata disease. The methylation of mercury in the lake sediment or sediments of other aquatic body is the key to the transport of mercury into food chain. Figure 7. 21. Figure point 7. Biomagnification of methylmercury in aquatic organisms. Apart from the toxicity and increase in concentration from lower to higher trophic level, the persistence of the metal in environment makes metal pollution difficult to control. The radioactive dust that falls on the earth after atomic explosion is called radioactive fallout. Fallout radionuclides are being passed on to man via food chain. For example, in Arctic and subarctic regions of Alaska and northern Finland reindeer and caribou meat is consumed. 137 Cs in man was higher during 1965. From the air, 137 Cs gets deposited in the reindeer moss lichen which is a primary producer. This lichen is a primary winter food for the caribou. It also showed high concentration of 137 Cs in winter. 137 Cs also showed food chain concentration which doubled with each trophic level in the food chain. The most severe nuclear reactor accident occurred on April 16, 1986 at the Chernobyl nuclear power plant in the Ukraine. The accident of Chernobyl produced a nuclear cloud and deposited much of contamination over Arctic Eurasia. The isotopes of 137 Cs, 134 Cs, 131I and 137 Sr were emitted and people living by the nuclear plant were most adversely affected. Much of the nuclear fallout from the Chernobyl site occurred in Scandinavian countries, Poland and 22. Some Northern Europe countries. 137 Cs caused much exposure to general public. Radioactive contaminated lichens passed strontium and cesium to reindeer. In vertebrate food chain, strontium and cesium usually accumulate, particularly at higher level. In arthropod food chain, radioactive elements like potassium, sodium and phosphorus accumulate while strontium and cesium does not accumulate. Because half-life of 137 Cs is about 30 years, its effect will persist for many years on the sites which have been exposed to nuclear fallout. Toxic pesticides as BHC, DDT are not easily degraded and are long-lasting in the environment. Their concentration therefore goes on increasing in water and soil in successive application. For instance, DDT in water may be very low, but the aquatic plants like phytoplanktons may show an average value of about 5.5 ppm, about 265 times increase over the concentration used in initial application of DDT. Plants and animals accumulate DDT in much higher concentration in these bodies. The herbivore, insects and fish feeding on these plants may accumulate DDT in still higher concentration and at the top carnivore level, fish-eating birds etc. Concentration may reach at very high level. Some shellfish as oyster accumulate DDT 70,000 times the original concentration, frog 2,000 times and sunfish 12,000 times. Maxwell 1973 presented on example of DDT magnification in food chain. The spraying on elm tree resulted in 99 ppm of DDT in soil, 140 ppm in earthworm and more than 400 ppm in robins that fed on these worms. The following is another example of biological magnification of DDT in aquatic system. Table 5. Table point 5. Biological magnification of DDT in aquatic system. Component concentration of DDT ppm, water 10 to 6. Zooplanktons 10 to 2, minnows 10 to 1, needlefish 1.0, birds 10.00. 23. The polychlorinated biphenyl PCBs compounds are group of man-made chemicals which are similar to DDT in their extreme stability. These are introduced in 1929 and are extremely toxic compounds which originate in a great variety of manufacturing process like manufacturing of glass, electric transformers, inks, carbon-less copy papers, grinding wheels, ceramics, varnishes, fire-resistant coating to wood and plastics, sealants, tires, plastic coating and many more. PCB can affect the immune system, fertility, child development and increase the risk of certain cancer. Because of the extreme toxicity, the accepted level of PCB in fish to be eaten is only 2 ppm. In higher concentration it causes death. The biological magnification of PCB in Great Lakes region of United States is shown in the figure 8. Herring gull 124 ppm. Lake trout 4.83 ppm. Rainbow smelt 1.04 ppm. Phytoplankton 0.0025 ppm 124. Zooplankton 0.123 ppm. Water 0.000002 ppm 124. Figure point 8. The biological magnification of PCB in Great Lakes region of United States. 24. The DDT molecule is stable and does not decompose under continued exposure to oxygen, sunlight or other reagents. Similarly, from biological point, DDT is also very stable. Only few microbes have the ability to degrade DDT efficiently and the process appear to require anaerobic conditions. In animals, DDT is metabolized very slowly by the liver into breakdown products DDE and DDD which are highly toxic than their parent compound. These factors combine to yield a half-life for DDT in the biosphere estimated at about 15 years. It is estimated that over 2 billion metric tons of DDT is circulating in the biosphere, of which 3/4 is distributed in terrestrial environment and the remaining 1/4 in marine environment. DDT enters the air largely through aerial spraying operation, but significant amount enters the air by simply evaporating from water surfaces, plant surfaces and soil. In this fashion, about 1/4 of the total annual production of 100,000 metric tons per year reaches the ocean. Even if it is never used again in future it would be still there for many years. DDT is a potent toxicant of water and soil. Many developed countries like UK, Sweden and Denmark have already banned the use of DDT. In India, the government has banned the use of more than 30 pesticides, and restricted the use of 7 pesticides including DDT. India also has BIS standard, Bureau of Indian Standard, for pesticide application equipment. However, implementation of legislation and standards at field level needs to be strengthened to prevent misuse and inappropriate use of pesticides. 5. Summary. The chemicals present in the environment can be harmful to the structure and function of the ecosystem. These chemicals are either produced naturally or artificially by humans. In 1960s the term ecotoxicology was introduced which deals with the interactions, transformation, fate and effects of natural and synthetic chemicals in the biosphere including individual organisms, populations, community and whole ecosystems. There are a number of ways through which toxic materials enter into the body of living organisms like water, air, food, accidental exposure, medicinal drugs and several other means. The toxicity can be categorized as acute toxicity which occurs as a result of single 25. Exposure to chemicals which immediately show its harmful effects and chronic toxicity which occur due to prolonged exposure of sublethal dose. The dose-response relationship is used to examine the time-dependent effect of exogenous and endogenous chemicals and physical agents. Toxicants adversely affect living organisms in different ways. Toxins that specifically cause abnormalities during embryonic growth and development are called teratogens. Thalidomide is the most commonly known teratogen which causes abnormality in developing embryo. Many chemicals in the environment are carcinogenic. It includes synthetic chemicals, radiation, air pollutants, heavy metals and smoking. Mutagens are agents, such as chemicals and radiation which causes sudden and permanent changes in the genetic material of living organisms. This can lead to birth defects or may trigger neoplastic tumor growth. Certain chemicals act as allergens that activate the immune system. Formaldehyde is one of the most common examples that act as a powerful sensitizer of the immune system. Accumulation of toxic compounds in food and through food chain represents concern related to the consumption of this food by human and other animals. Toxins when absorbed in the body are metabolized, transported or excreted. During the metabolic process, they have adverse biochemical effects. These processes are characterized by kinetic phase and a dynamic phase. In kinetic phase, a toxic substance may undergo absorption, metabolism, temporary storage, distribution, and excretion. In the dynamic phase, a toxicant interacts in cells, tissue, or organ in the body and leads to various types of toxic effects. There are certain chemicals in the environment which have the tendency to become increasingly concentrated at successive higher trophic level of a food chain or food web. This is known as biomagnification or biological magnification. Due to this process, toxic compound reaches to dangerous level inside cell and tissue of living organisms. The effect of DDT, PCB, heavy metals and radioactive materials get magnified through the food webs. Due to biomagnification, DDT interferes with the reproduction of peregrine falcons, bald eagles, brown pelicans and other predatory birds by causing thinning of egg shells. The incidence of neurological disorder affecting many fish-eating people in the industrial city of Minamata Bay in Japan is a good example of biological magnification of mercury. 26. Due to higher toxicity of DDT, many developed countries like UK, Sweden and Denmark have already banned the use of DDT. In India, the government has banned the use of more than 30 pesticides, restricted the use of 7 pesticides including DDT. However, implementation of legislation and standards at field level needs to be strengthened to prevent misuse and inappropriate use of pesticides.